Hello friends, today we will study about manufacturing defects. Our video includes casting defects, welding defects, extrusion defects and drawing defects.
Defects. During casting process, several undesired irregularities creep into the final casting product. These irregularities are known as casting defects. Thus, casting defect is any undesired irregularity in the metal casting product. Casting defects are broadly classified into gas defects, molding material defects, pouring metal defects, and metallurgical defects. Now let's discuss each of these defects one by one. Gas defects. These defects occur due to the improper gas passing tendency of the mold. They are further classified into air inclusions, open blows and blowholes. Air inclusion is air trapped in the final casting product caused by improper ventilation during casting process. They are controlled by choosing appropriate pouring temperature and improving gating practice by reducing turbulence. Open blows and blowholes are the spherical or elongated cavities formed on the surface or inside the casting due to the moisture present in the mold and core or lower ventilation and permeability of the mold. Proper ventilation is the remedy of eliminating open blows and blowholes. The cavities formed on the surface of the casting are called open blows, while those formed inside the casting are called blowholes. Molding material defects. These are the defects caused by the characteristics of molding materials. They are further classified into runout, fusion, cuts and washes. Runout is the leaking of molten metal out of the mold due to the faulty making of mold or faulty molding flask. Fusion is the brittle and glassy appearance on the casting product due to fusion of sand grains with the molten metal, caused by lower refractoriness of molding sand or very high temperature of the molten metal. This defect can be removed by selecting an appropriate type and amount of clay such as bentonite. Cuts and washes are the rough spot and area formed by excess metal present in the casting, caused due to the erosion of molding sand by flowing molten metal. This happens due to weak strength of molding sand or high speed of flowing molten metal. The former cause can be remedied by selecting proper molding sand and using appropriate molding method, whereas the latter cause can be remedied by increasing size of gates or using multiple ingates. Pouring metal defects. These are the defects caused by the properties of the molten metal being poured. These are further classified into slag inclusions, misruns. When flux is added in the molten metal to avoid impurities and oxide formation in the hot molten metal, some of the slag formed by the flux enters the casting. This presence of slag in the casting product along with the molten metal is known as slag inclusion. Adoption of some of the slag trapping methods like pouring basin screens and runner extensions eliminates the possibility of slag inclusions. Misruns are caused due to the low fluidity of the molten metal and less thickness of the casting section. Misruns are formed when molten metal does not fill the mold cavity completely, thus leaving unfilled cavities. Misruns are eliminated by selecting proper casting design and by increasing fluidity of molten metal. Metallurgical defects. These are the defects caused by the properties of the casting product. These are further classified into hot tears and hot spots. Hot tears are unwanted cooling stresses developed in the casting product due to the poor casting design, which may cause the product to rupture. Hot spot is the formation of very hard white cast iron on the surface of casting made up of grey cast iron and small amounts of silicon due to chilling of the casting, that is, when the casting is cooled suddenly. The hot spots can be eliminated by adopting proper metallurgical control and chilling practices. Related term is In welding defects and its types. Sometimes the weld produced during the welding process may possess some flaws, such as slag inclusion, porosity, etc., which can hamper its usefulness. Such flaws are referred to as the welding defect. Thus, we can say that welding defect is the undesired irregularity present in the weld produced during the welding process. The different types of welding defects are undercuts, incomplete fusion, porosity, slag inclusion, and spatter. Undercuts refer to the unfilled grooves present along the edges of the weld. They mainly occur due to improper welding technique, excessive welding current, and incorrect manipulation of the electrode while depositing the weld bead. Undercuts can be avoided by using large electrodes and moderate current by moving the weld torch slowly over the metal work pieces, and by placing the electrode at a safe distance from the interface of the work pieces. Incomplete fusion refers to the discontinuity in the weld zone. It mainly occurs due to improper penetration of the joint, wrong design of the joint, and by incorporating incorrect welding technique. Incomplete fusion can be avoided by supplying low electric current than required, and by cleaning the joint properly. Porosity refers to the cavities or pores caused due to entrapped gases in the molten metal during the solidification process. It mainly occurs due to contaminated gases in the molten metal. Inadequate shielding, unstable arc, small arc gap, and poor welding technique. Porosity can be avoided by proper selection of the electrodes and filler materials, and by decreasing the speed of the welding torch. Slag inclusion refers to the slag present in the welding product. Slag is formed due to the fluxes added during the preparation of the hot molten metal. It mainly occurs due to high viscosity of the weld metal, rapid solidification, and insufficient welding heat. Slag can be removed from the weld metal by grinding, wire brushing, and chipping. And spatter refers to the drops of metal expelled from the weld which sticks to the welding surface. It mainly occurs due to high welding current, long arc, incorrect polarity of the arc blow, and improper gas shielding. Spatter can be avoided by decreasing the welding current and arc length, by using arc having correct polarity, and by checking the correct shielding gas type and its flow rate. Related term is defects. Irregularities observed during the process of extrusion are known as extrusion defects. Most defects are created by non-uniform material movement through the die and stress distribution during the process. Number of defects depend upon wall friction and wall temperature. There are mainly three types of extrusion defects, namely surface cracking, piping defect, internal cracking. Now let us discuss about each defects. Surface cracking generally occurs due to rise in surface temperature. Here are some examples of surface crackings which are common. These cracks are intergranular and usually the result of hot hardness. These cracks can also occur at low temperature when extruded material sticks to die. Internal cracking occurs when cracks are developed in center of the extruded material, also known as center cracking, center burst, chevron cracking, and arrowhead fracture. These cracks develop due to the difference in flow of metal in outer part as compared to central part. Outer part has more velocity as compared to central part, resulting in stress developed in central part. These cracks are often hard to detect as they occur within the material of the part. These cracks can be prevented by using appropriate die angle and higher friction and high extrusion ratio. Piping generally occurs in hot extrusion. When metal in contact with the walls cools down rapidly as compared to central part resulting in a non-uniform flow of metal. These defects are created by surface of oxides and impurities being drawn to the center of the extruded material. Piping defect propagates as a funnel-shaped void to the end of the material, also known as tailpipe and fishtailing. These defects can be prevented by modifying flow pattern by controlling friction and temperature, machining the billet surface prior to extruding, using a dummy block that is smaller in diameter than the container. Thus, we can summarize as are drawing defects. The drawing defects are mainly classified into two types: internal cracking, surface cracking. Internal cracking. Internal breakage may occur in drawn products, particularly along the center line. This defect occurs when drawing takes place at low temperature. Surface defect. Surface defects such as seams, scratches, and cracks are all possible defects on the surface of drawn product. Excessive force on the surface of the work during the drawing operation can be cause of breakage. Thus, the drawing defect are broadly classified as surface defects and internal cracking. Related term is